Welcome to our crazy short video lecture on solubility curves. Our objectives for today, we're going to define saturated, unsaturated, and supersaturated solutions. Then we're going to use some solubility curves, some lovely graphs to figure out just how saturated our solutions are. So this idea of saturation is all about trying to max out how much stuff is dissolved in our solution. So an unsaturated solution has less than the maximum amount of solute possible dissolved. This beaker of water, 100 milliliters of water, we can add 30 grams of salt. All of it will dissolve, but because I have space to dissolve a little bit more salt in this water, it is considered an unsaturated solution. Saturated solutions do have the maximum amount of solute possible dissolved. So if I add 40 grams instead of 30 grams to that same 100 milliliters of water, what happens is 36 of it will dissolve. But we'll have this tiny little pile on the bottom, 4 grams of salt that cannot be dissolved in this water because I have saturated this quantity of water. We have dissolved as much salt as possible in those 100 milliliters of water. So this is a saturated solution. Supersaturated solutions are super cool. What we can do is actually increase the temperature and therefore increase how much solute we can dissolve. So here I've got a saturated solution. If I heat it up, I can actually get just a little bit more stuff to dissolve in my solution. And then if we cool it off very, very slowly, that increased solute might not crystallize. It might stay dissolved in the solution. And then we would call this a supersaturated solution. But these guys are crazy unstable. Any little disturbance, a little ping on the side of the flask, and it's going to crystallize really fast. Solubility curves help us know where saturation points are at different temperatures. So these curves show us the relationship between the amount of solute that we can dissolve. In this case, we've got 100 milliliters of water, and at different temperatures. So notice sugar here, so this is sucrose. At 0 degrees Celsius, we can dissolve maybe about 175 grams of sugar. But if I heat it up to 60 degrees Celsius, then we can get, I don't know, what is that, 280-ish maybe. So we can increase the solubility of sugar by heating up the water that the sugar is being dissolved in. Salt, however, there is a small increase, but not much, right? So we definitely have maybe 40-ish grams of salt can be dissolved at 0 degrees Celsius, and then it's 60, maybe 41. It's not a big difference at all. Sometimes we make our solubility curves super confusing by throwing lots of lines on the same graph, but they're still readable as long as you focus on one line at a time. So here, how many grams of potassium chlorate will dissolve in 100 milliliters of water? 100 grams, 100 milliliters, just about the same thing since we have a density of water 1 gram per milliliter. So I'm looking at 30 degrees Celsius. I'm going to go to 30 degrees on my x-axis here, and I want to find the line for KClO3. KClO3 is here, so I'm looking at this line right there. So I go to 30, I go to where I run into the KCl line, and it looks like we can dissolve just about 15 grams can dissolve in those 100 milliliters of water at 30 degrees Celsius. So this would be our saturation line. This is the maximum amount of the solute that we can dissolve at this temperature. I'm going to have you do these two in the Ed puzzle. How many grams of Ki, potassium iodide, that line's way up here, will dissolve at 15 degrees Celsius, and then at 50 degrees Celsius, how many more grams of sodium nitrate than potassium nitrate will dissolve? So answers, how many grams of Ki, potassium iodide, at 15 degrees Celsius? 15 is just about here, so if we go all the way up to that Ki line, it looks like we've got just about 140 grams of potassium iodide will dissolve at that, I am not drawing a very good straight line, 15 degrees Celsius. And then this one, sodium nitrate at 50 degrees Celsius. We go to 50 degrees Celsius, find sodium nitrate. It is right here. So here's sodium nitrate's line. That looks to be just about maybe 113 or so. And then potassium potassium nitrate is here, also at 50 degrees Celsius. This looks to be maybe about 85. And so we can do 113 minus 85, and that's going to give us just about 28 grams more of sodium nitrate can be dissolved than can grams of potassium nitrate. Good? Good. We can also use our solubility curves to determine if solutions are saturated, unsaturated, or supersaturated. So our line actually gives us the maximum amount of solute that can be dissolved in 100 grams of water at each of these temperatures. So our line is exactly saturated. If I have less than the line, then that is going to be unsaturated because we have less than the maximum amount possible dissolved. But if I have something over the line, that is supersaturated because we have greater than the maximum total possible solute dissolved in our solution. So here I've got 20 grams of NH3 ammonia dissolved in 100 grams of water because my graph tells me 100 grams of water at 70 degrees Celsius. I need to determine if it is saturated, unsaturated, or supersaturated. So I'm going to go to 70 degrees Celsius, 70 degrees Celsius. I'm going to find 20 grams. 20 grams is right there. So 20 grams, 70 degrees Celsius. Now I'm going to find my line for NH3. It's this one right here. And notice that our line pretty much goes right through that point that we drew at 70 degrees Celsius and 20 grams. And so this solution is saturated because we are on the line, and the line tells us saturation point. I want you to go ahead and determine if 10 grams of SO2 at 30 degrees Celsius is saturated or unsaturated or supersaturated, and then do the same thing for this last one, 60 grams of ammonium chloride. Be careful, in 50 grams of water at 90 degrees Celsius. Is this one also saturated, unsaturated, or supersaturated? All right, let's look at this one. 10 grams of SO2 at 30 degrees Celsius. We go to 30 degrees Celsius. We go up to 10 grams. That's right there. Our line for SO2 is here. We are over the line. That makes this supersaturated. It's a supersaturated solution because we have more than the maximum total possible dissolved at that temperature. How about this last one? So now I'm looking at 60 grams of ammonium chloride and 50 grams of water. The challenge here is that my graph gives me 100 grams of water, so I have to scale up. If I have 60 grams of ammonium chloride in 50 grams of water, then 100 grams of water should be 120 grams of ammonium chloride. So I'm going to go to 90 degrees Celsius, 90 degrees Celsius, all the way up to 120, all the way up to 120 grams. Now I'm going to find my line for NH4Cl. Ammonium chloride is right here. We are so much above that line. This is also going to be a supersaturated solution. Make sure that you're checking that 100 grams of water so that you can use the graph appropriately. And we did it. Objectives met. We defined saturated, unsaturated, and supersaturated solutions, and then we used those solubility curves to determine just how saturated some solutions are.